Okay, I'm going to attempt to record some calculator steps for you to show you how to determine using your graphing calculator if an equation that you're given is an identity or if that identity is true. I did tell you that it doesn't matter if you're in radian mode or degree mode. However, this here where it says connected, you actually want to change that, in this case, to dot mode and hit enter. Now from there we can go into the y equals and we can put in each side of that equation that you're given. You'll put one in as y1 and the other one you'll enter as y2. The way I do that is I put parentheses first, and I will make this tangent of x, close that parentheses, squared plus 1. And then I want to see if that's equal to secant squared of x. So I do 1 divided by the cosine of x squared. Now I also gave you a window, and that's going to really be dependent upon whether you are in radians or degrees. I've kept mine in radians, so I go from negative 2 pi to positive 2 pi, and I'm going to set my scale as pi over 2. You can leave everything else exactly as it is, and then from here you push graph. Now it's done graphing and we only see one graph. What that tells us is that these two components, tangent squared of x plus 1, is in fact equal to secant squared of x. For this problem, we're being asked to write this expression in terms of sine and cosine. One of the things that you're going to figure out when we get to the next section is that sometimes you want everything to be in terms of sine and cosine because then you can work with it a little bit easier. You are also told that you need to simplify this expression as much as possible. And although the final answer won't look simplified, it actually will be considered simplified. So let's get started with that. First, we know that secant of theta is the same as 1 over the cosine. And cosecant of theta is 1 over the sine. And you might think, okay, done. That's the most simplified thing. But this still isn't quite where we want to go with this. We actually want to combine these so that they're one term. And the way that we do that, remember, to add fractions, you need a common denominator. So, since we don't really have a common denominator, what we'll have to do is we'll have to multiply each fraction by some version of 1, means by something over itself, so that it will have the same denominator. The best way to figure this out is to look at your two denominators. I see that one denominator is cosine and the other is sine. So what I will do is I'll multiply this first fraction here by the sine of theta over the sine of theta, and I'll multiply the second fraction by cosine of theta over cosine of theta. When I do this, remember when you multiply fractions, numerator times numerator, denominator times denominator. So the first fraction becomes the sine of theta over sine of theta times cosine of theta. And there's my plus sign. And then I multiply numerator times numerator, denominator times denominator. And I get cosine of theta over sine of theta times the cosine of theta. Now what you should be able to recognize is that my two denominators are the same, sine of theta, cosine of theta, sine of theta, cosine of theta. Remember, when you're adding fractions, you add your two numerators together, and then your denominator will stay the same. So when I add my numerators, I get sine of theta plus cosine of theta divided by sine of theta times cosine of theta. A lot of you are going to want to start canceling stuff out. You cannot do that. This plus sign is here to tell you that you cannot just start canceling things. And as a matter of fact, this is your simplified answer.